Welcome, everybody. Thanks for joining me. Just read another article I wanted to share, and it's basically asking does random chance dictate how stars form, or does the mass of the star cluster determine how massive its brightest stars will become? That's really kind of my takeaway from the article. So, when the Milky Way or any galaxy develops new stars, they're usually formed inside vast molecular clouds of dust, and they form into star clusters. And we usually call these open clusters. And here's a sketch of an open cluster that I did back in this fall. It's NGC 637. It's an open star cluster in Cassiopeia. And just from the sketch, you can see there's a variety of sizes and different types of stars within that open cluster. There's just a diversity of stellar types there. Some of them are small, some of them are cool, some are like our sun, some can be massive, 10 times or larger than our sun, and have a much greater, hundreds of thousands of times of more luminosity, brightness to them. And so, anyway, those stars that are much brighter, much larger, they have a much shorter lifespan than a star like our sun. A star like our sun will average 10 billion years. A massive star, millions of years, anywhere 6 to 10 to 12 million years, depending on its size. So when we look at a galaxy, then we tend to find a difference in the mass in these open clusters has significant impact on how bright a galaxy is. For example, a dwarf galaxy may have a total mass that's low, so it's not going to really produce any extremely massive stars much brighter than our sun. It's just the mass isn't there for it. So that kind of raised a question that some researchers looked at. Does the actual mass of individual stars in a cluster, is that a matter of chance or not? Professor Pavel Krupel from the Helmholtz Institute of Radiation and Nuclear Physics at the University of Bonn and his doctoral student Karsten Weidner in 2006 examined this. And what they found was that the most massive star in a cluster is determined by the mass of the star cluster itself, basically the mass of the molecular cloud that it forms from. They then used that research to develop a concept called optimal sampling, and that enables the distribution of the stars in a young population to actually be calculated. And he states when stars are formed into a gas cloud, their masses aren't decided at random, but follow a precise order that leaves no room for statistical fluctuations. This can only happen if star formation process is extremely self-regulating. So until recently, physicists could not explain this self-regulation process and how it occurs. Dr. Ida Gregorio from Nanjing University in China, who was the first author of the study, used this concept developed by Dr. Krupa to establish an approach according to which the star cluster develops in lines with a specific efficient principle. Out of all the possible mass distribution scenarios, she says, what actually plays out is the one that's the most natural for large scales and the least dependent on microscopic details. Dr. Krupa says the work is opening up a new way of formulating theories about star populations. We only need to have a number, namely the mass of the star population, in order to know what kinds of stars and how many of them are going to form from the molecular gas cloud. This is enabling us to make highly efficient calculations about the evolution of galaxies because we no longer have to perform thousands of calculations for a single one, saving much of our supercomputer time and thus energy as well. So as a result, there's a whole host of calculations on the evolution of galaxies that's going to need to be redone. Dr. Krupa says, contrary to what the previous theory suggested, small dwarf galaxies do not form any massive stars, and this has a fundamental impact on the theory of matter cycle in the universe. Anyway, it's just fascinating. Next time you look at it or image or observe an open cluster, realize really the number of stars and the type of stars there are determined by the molecular gas cloud they form from, and actually that helps to determine what type of galaxy we're looking at. So very fascinating stuff. Hope you found this interesting. Go to Easy Astronomy, get a link. I have the article there that I wrote and a link to the research paper there if you want to read it for yourself. Hit the subscribe button if you like what you're seeing here. Appreciate your time, and I hope you have clear skies, and we will talk to you next time. Thanks again.